Hi everyone. I'm going to talk to you about running linter rules, why, how, and when. So, a little bit about myself. My name is Jeroen Engels. It's a Dutch name. I'm used to people mispronouncing it. I go by JFM Engels everywhere. I have a blog with that same name. And I'm an engineer at CrowdStrike, which is a large cybersecurity company. And I specifically work on the LogScale product, which is a log management system. Basically, you can send all of your logs from servers to our product, and we can store it efficiently and very cheaply. And then you can, using our interface, find all your logs in a very fast manner. So if you're looking for a log management system, then you can check out LogScale. And in my spare time, I'm the author of a tool called Elm Review, which is a linter for the Elm programming language, and the co-host of the Elm Radio podcast, where we discuss tools and techniques for the Elm language. So I like Elm. Most of my examples are going to be JavaScript, TypeScript, because I think that's going to be familiar to most of you, but that's not an endorsement. Do check out Elm. That's what I would recommend. So, my aim with this talk is to provide you with the instincts of when to use a linter, and specifically custom linter rules. This is not going to be a tutorial, because every programming language has their own linter, or linters, and they all work differently. So if I try to make a tutorial for one, it's not going to be applicable to others. So I'm going to try to keep this pretty generic. If you like what you learned today, then you can go to your favorite linters documentations and see how to make a linter rule for that one. All right. So, what is a linter? A linter is a pretty simple tool that looks at your code and reports a bunch of errors. It's going to report things like common bugs, report unused variables, ways to find ways to simplify your code, and enforce a specific code style. So there's quite some overlap with another tool in the same domain, which is a compiler. And a compiler is going to compile your code to a binary or something like that. And if there are problems, then it's going to report errors. So for the compiler, it's usually if the code is very incorrect or too incorrect for the compiler to make something out of it, then it's going to report the problems. For linter, it's usually going to be things that are either less problematic or less obvious to the compiler. And if your language doesn't have a compiler, because it's a dynamic language, for instance, then all the checks that a compiler will do are usually written as a linter rule. But a linter also is usually very customizable. So a linter comes with a lot of built-in rules, and you can choose which ones you want to enable and which ones you don't. And among those, you can even configure them. So you can have a rule that says, well, I want semicolons everywhere, or I want semicolons nowhere. And then the best linters out there, in my opinion, are the ones that provide the ability to write custom rules. Because these tools come with a lot of built-in rules, but these are all going to work for the general programming language community. They're not going to work specifically for your project. These are things that we're going to look into it for this talk. So, the point of view that I like to look at tools from is from the point of view of guarantees. So, we are developers here, mostly I'm guessing, and we try to make products that help solve other people's problems directly or indirectly. But unfortunately, because we're humans and we're dealing with very complex systems, we make bugs. And that's okay, that's going to happen, because we can fix them. But as we grow more experienced, what we try to do is to find tools and techniques to prevent those bugs. And we have very different tools to do that, and linters are one of those. So to start off, I want to go through different tools to show you how they guarantee that you don't have bugs. And then we can see how they work together with a linter. So I'm going to go through a few examples. It's in JavaScript, TypeScript, sorry. So here we have the function shout, which takes a sentence and it calls two uppercase on that sentence. And then we call shout with 100. So if you send this to production and a user ends up running it, this is going to crash because a sentence is supposed to be a string and we're giving it 100. So this is a bug. That's okay, we're gonna fix it. And that's probably gonna be pretty easy. But how do you prevent this from happening ever again? How do you cancel these classes of problems? Well, we're gonna look for tools and techniques to mitigate that. And the tool that we're gonna choose will depend on the problem. So here we have a type error. And for that, there's a very good tool to do that, and that is called a static type checker. So most statically typed languages, they come with this already. Some other languages like JavaScript and Python, they have a separate tool for that, TypeScript and MyPy. And then what we end up doing is we annotate our sentence argument to be marked as a string. Now, if we run a type checker, then the type checker is going to basically compare values and sets of values. So this hundreds that we pass into shout, then the compiler knows, okay, well this is a number, but we're expecting it to be given as we're expecting sentence to be a string. So is 100 in the set of strings? Yes, no. In this case, no. Therefore, there's a type mismatch, and it's going to report an error. And this is going to block our test suite, and this is going to prevent us from sending this to production, meaning that shout will never crash again, at least for this issue. Here's a different example. So we have a function can delete users, which takes a user role, which is either user or admin. And we say, well, if the user role is admin, then yes, we can delete users. And otherwise, yes, we can delete other users as well. That's a bug. Clearly, that's a bug. So this is going to be fairly easy to fix. We're going to change return true, the second return true to return false, so that regular users can't delete other users. But how do we prevent this from happening again? Right? Can we use a type checker? Actually, no, because true is indeed a correct value. It is in part of the set of booleans. So from type checker's point of view, this is fine. What we're interested in this case is mostly that given a specific input, you get a specific output. And that is exactly what a test is for. Because tests, what they do is you write different scenarios in which you test that specific variables have specific values. That is what a test is. So here what we do is we check that, we run a test that asserts that can delete users given user returns false. And then we update the function. And now, as long as we have this test, we get the guarantee that regular users can't delete other users. So one thing you might notice is that every time we want a guarantee, we're actually adding a constraint. So by adding the constraint that we can't call shout with something else than a string, we get the guarantee that shout won't crash the application. By adding the constraint that candidate users should return false given the input user, we get the guarantee that regular users can't delete other users. So basically, a guarantee is the same thing as a constraint, or there are two edges of the same coin. I've also heard it called a liberating constraints. Just happened to see that yesterday, and I think that's a nice name. So, last example. Let's say we want to make HTTP calls to our API. So what we do is we import the core HTTP module, which comes with our language, which I'm kind of inventing, it's not really JavaScript code. And we have a function to create a user and a function to delete a user. So create user calls http.post, we give it the URL to hit, and we give it an authentication token, which we should absolutely not forget, otherwise the server is gonna tell us, hey, you're not authenticated, I'm not doing this for you. So we should absolutely not forget that. And then we pass it some data. And delete user calls http.delete, we pass in the URL, and we forgot to pass in the authentication token. So again, this is pretty good. This is going to be pretty easy to fix, but how do we prevent this from happening again, right? Can types help us? Well, probably not, because the core HTTP module has not been written by us. We don't control what types it takes, which types it doesn't accept. So from its point of view, it is absolutely fine that there's no authentication token. So types won't help. Can we write tests? Yes and no. If we try to test these in unit tests, then we're testing the implementation. And that is bad. There's plenty of reasons why that is bad. We could probably test this using end-to-end tests, but those are expensive. So what I choose to do, what I would probably do in this case, is that I would define a wrapper around this HTTP module, which I'm going to call custom HTTP. So I'm just redefining the functions that we have in HTTP, but I'm adding, I'm changing the body, the parameters to the function to force that there is an authentication token. And now the type checker is going to enforce that there will always be the authentication token. So we're just going to use that in the code before. And now, if I ever forget to pass in the authentication token, I will get a type error, which is really nice, which is very quick feedback. So you're not happy, you fix this problem, and you tell everyone at your company, hey, we should always use custom HTTP instead of HTTP. It's simpler, it gives us these guarantees, we're very happy to have that one. Don't ever import HTTP. Guess what happened next? Someone who's new at the company, who just forgot about this announcement, figures out that they need to add a edit user functionality, and for that they make a call to the HTTP, to the API. And they do that using the core HTTP module, which is not what we agreed upon. So if you happen to see this during your code review and you remember that there's this rule that we shouldn't use the custom HTTP module, you're going to report it. But otherwise, maybe it will go through and maybe they forgot to add the authentication token, who knows. But anyway, you don't want to see this code again for different reasons. So how can we prevent this from happening again? Types, not going to help. Tests, probably not going to help. Also, someone needs to write those tests, and this person clearly hasn't remembered that they should, even if they could. So this is a bit annoying because the tools that we have at our disposal don't help us with this, right? But it's a bit frustrating because you can just look at the code and you can tell clearly, I mean, someone is just importing HTTP, and that shouldn't happen. And when you can tell that, well, that's exactly when you can use a linter, because that's exactly what a linter does. It looks at your code and it reports errors. You just have to tell it which rules to enable, to enforce. So what we're going to do is we're going to build a small linter to do this job for us. But what I like about this, and this is the way I view all of my tools, is that every tool has a different angle of how they create guarantees. So the type checker looks at values and sets of values. Is this value part of this set of value? Yes, okay, no, there's a type mismatch. Tests, what they do is they look at specific values given some scenarios that you create for them. And linters, they can also create guarantees, but the way that they approach it is not based on those types nor on values, it's based on how the code was written. And sometimes that is exactly the approach that you need to have to create a specific guarantee. So we're gonna build a very simple linter using a very fancy tool which is called grep. So for those who don't know, grep is actually a very simple tool. It's basically just finding some text in some files. So we're gonna just look for from HTTP in our source files, because if we ever see from HTTP, well then that's a problem. That's all we care about. So I'm gonna make that into a small bash script. It's pretty much the same code. So we're doing the same grep command. I'm adding the file name, the line number, and some color so it's fancy. And then we're going to exclude the custom HTTP file because that one is allowed to import the HTTP model. That one needs it. And then if we ever find a match, then we're going to print out some error. We're going to print out where it is happening, and we're going to exit with code 1 so that it fills our test suites. And this will block us from pushing this to production. And we get this error message, which is okay. And I mean, this is a very simple linter, probably the simplest that you can make, that I can make at least. But it's a bit naive, it's a bit too naive. And that's going to give us some false negatives. So false negatives when a tool doesn't report an issue when it should have. So because grep is only looking for specific characters, if the characters are slightly different, it's not going to match. So we're looking for specifically from space double quotes HTTP double quotes. So if we happen to have single quotes, that's not going to match. It's not going to find it. If we have too many spaces, if we have 2 spaces after from, it's not going to match. If we have it on several lines, it's not going to match it either. And we can probably improve the pattern a little bit, but if you, this is some of the limits that you have with finding byte text, where if you have something more complex than this, it's going to be really hard to figure out all the cases. And you also have some false positives. So for instance, if you have a string or a comment where it says, don't ever import HTTP, which is good advice, well, that's going to be flagged as well, and you don't want that. So what linters tend to use is not this approach of finding things by string. Instead, what they use is called an abstract syntax tree, or the AST for short. And that is basically a data structure represented in the shape of a tree that represents the structure of a code. So for instance, if we have the expression a plus b divided by 2, that could be represented as this tree. All the names for the nodes are different for each linter. So we can have at the root a binary expression using slash. On the left side we have a parenthesized expression which contains a binary expression with plus. On the left side a reference to a, right side a reference to b, and the very far right integer 2. So what a linter will do is it's going to take your code, parse it into this structure, and then it's going to traverse this tree node by node. And for every node, it's going to ask the different rules. Hey, I have this node, like this one is a binary expression. Do you find a problem with this? If so, yes, then you're reporting an issue to the user. And otherwise, you ignore it and you just go to the next one. And that is exactly what a linter does. It makes it very easy to find some patterns. Basically, we're pattern matching on the AST. So let's say we wanted to have a simple rule to report divisions by 0. Well, in that case, the only thing we care about is that at some point we find a binary expression using slash, and then on the right side of that, you have an integer 0. If you find that, you report an issue. And that's a very, very simple rule. Written as code, that could be, you can write it kind of like this. where you have a visitor, because this is called the visitor pattern. And basically you check, is the type of for this node a binary expression? Is its operator slash? Is the thing on the right an integer? And is its value 0? If so, report an error, and otherwise, ignore it. And if we take that back to our example for the HTTP import, the node we're going to care about is the import declaration node, where if the source happens to be HTTP, then we're going to report that. And that's, I mean, all that we need for this kind of work. But in some cases, we're going to need to do a little bit more. We're going to need to collect information as we go through the tree. So for instance, if we want to report unused variables, what we're going to care about is the variable declaration nodes. They all have name, and in this case it's name. And every time you encounter these, you can't just report those. Because if you did, you would report all variables, not only the unused ones. So you're going to need to combine it with a different information, which is all the references to this variable. So if I have hello plus name, then I have some expression which at some point contains reference to name. So what I'm going to do is I'm going to collect all the names for the declared things, and I'm going to collect all the usages of variables, and I'm going to combine those, and that will give me the unused variables. Written as simple code as I could make it, we start with a list of empty declared things, a list of used things. Every time we find a variable declaration, we add it to the list of declared things. Every time we find a reference, we add it to a list of used things. And then once we revisit the entire file, then we take the difference, which gives us the unused variables, and we create an error for each one of those. And the fact that you need to collect information is actually pretty common. Like there's a lot of rules that need some kind of information collection. For instance, like if you want to know how a variable was imported, you're going to need to combine the import declaration with how it's used somewhere else. So this is something that is common to a lot of linters. So this was a very brief introduction to how to create a linter. If you want to know more about that, go check out your own linters documentation. But now we're going to look at some examples of what you can do with this. This is not going to be exhaustive, but these are things that you can use for your own projects. So I mentioned that using for the example for HTTP, that you can enforce that people use custom solutions instead of built-in ones. So for instance, in one of my previous projects, we had a lot of UI work, and we had every button define their own color, meaning that things were a little bit inconsistent. So you had a primary button in one part of the application that used a slightly different color than a similar button in another part of the project. And that wasn't great. So what we ended up doing is we moved them all to a single module, and we forbid people from creating their own colors inside the code. So this would be reported. And we gained two guarantees with that. Is that one, only colors that were chosen by the designer could be used, meaning that they will look quite well together, and they would represent the brand quite well as well. And if you wanted to change one color, you would only have one location in the code base to adapt that in the colors module. And we use this pattern for a lot of things. For instance, we have at my current job, we have an image rule to report the usage of the image function, which creates an image. But images always need an alt text for accessibility purposes. And we just forbid the usage of the core image function, and we say instead you should use this function, which always requires an alt text, enforced by the texture. Another thing that we could use this for is, or linter for, is to enforce that some things are unique. So we in my current code base, we have a file which contains a lot of IDs. And all of these need to be unique. So this is going to be really hard to do with types or with tests, but you could just have a linter go through every value and check that these are unique. And if there's one that is duplicate from another, then we can report it. Something that is pretty common in the Elm communities somehow, but I don't know if it's the same in other communities, is that we define some enumerations, like the menu items that you have at the top of your application. And somehow they all need to be in one array because you want to map over it or you want to do something like that. Surprisingly common in Elm. And people had different tricks to make sure that every time you add a new enumeration variant, you would not forget to add it to the list. And this is pretty trivial for linter because you can just look at it like, hey, this does not contain some kind of variance. I'm just going to report it. You can also impose some code architecture restrictions. So for instance, if you have an internal module that should only be accessed by the modules next to it, like the direct variance or something, then if you find that another module far away tries to import it, well, you can report that as like, no, you shouldn't touch that. And that guarantees that no one touches those internals. It gives you some encapsulation, and that reduces coupling. And basically, I'm not going to give you all the answers, all the things that you can do with it, but anytime you mention something during a code review, you're like, oh, you should never forget to do this, or you should never do this. Well, maybe you can automate that using a linter rule. Because in a way, a linter is simply a glorified and automated code review tool. A lot of large companies that deal with this call themselves code review tools. And there's another thing that you can do with a linter, and that is to enforce code style. How many people, when they hear linters, think about code style primarily? Not that many. Okay, you're still raising your head. That's not a thought. Good. Because a linter is not for code style, in my opinion at least, and more and more linter authors' opinion as well. So there are two subparts to this, to code style, that is layout and formatting, so that is dealing with indentation, line breaks, where the curly braces go, and etc. And then there's the rest, which I call stylistic preferences. So I see more and more linter authors agree that a linter is not the right tool for layout and formatting. There's a much better tool for that, and that is called a code formatter. So that's a tool that takes your code and reformats it in a very consistent way. So we have one in the Elm community which is called Elm Formats, and we love it. Because just in this file alone, you can see pretty much 95% of all of the Elm syntax, and all code will look exactly like this. So it makes things very consistent. And it will do this in a much more efficient manner than a linter will be able to do that. Because the linter, you will have to configure many rules to get the same results. But a code formatter often is not even configurable at all. So consistency is great. That is one of the reasons why we love code formatters, because now, for instance, you can predict how a variable declaration will look like, how it will be formatted. It makes it very easy to find, even just with a simple find in your editor or a grep. But for other things like stylistic preferences, I noticed that people usually enforce those kind of for the sake of it. So someone might think, well, I kind of like writing my code this way, I'm just going to enforce it, not thinking it very much through. And as we've seen before, like a constraint is a guarantee. So when you add this constraint, what is the guarantee that you gain from it? And if the answer is, well, not that much, then it's probably not worth it. And also it will be able to create a lot of pain sometimes, which brings me to when is a linter rule not appropriate? And one of the cases is when you have lots of exceptions. And this is especially true for code style rules, but not only. So let's imagine that we enabled or we wrote a rule that forbids short variable names. Because someone saw this code, they were like, I can't read that. I necessarily need to read the code that is surrounding it to understand what this means. But if we enforce that the variable names were longer, well then it will be much more readable. And that might be true. But there are a lot of exceptions. For instance, for loops usually use the variable name I, which I think everyone understands here. So should we add an exception for this one? Maybe. And if we don't, maybe we want to add a disable comment to make sure that the linter doesn't report this. So I is an exception. What about J, which is also quite common? K sometimes. N is also a very common variable name, just to represent a number. So, yeah. And also, like for instance, some functions are extremely generic, and just longer names don't really make sense. So for instance, if I have a function that just does A or B, does it help the readability if we force it to be left or right? Because now I think, oh, maybe there's a concept of left or right in this part of the code. And no, there isn't. But someone forbid me from naming it A or B, so I'm going to have to find a better name, right? So every time you enable or you write a custom rule, you need to think about all the edge cases, or as many as you can think of. So what false positives or what false negatives is this rule going to have? And how painful will they make the experience for the user? Because I don't know if you've ever used linters where you keep getting these bad reports, but they're pretty known for those, mostly, in my opinion, because we enforce dumb rules that either don't make sense or they report way too many false positives. And I don't think they've been thought through, or that the programming language makes it easy for the linter to do a good job. That said, if your team agrees to enable a rule, that's fine. If everyone on the team is fine with it, go ahead. But if it turns out that you're getting a lot of pain from enabling this rule, then I would really recommend that you, after trying it out, remove it. So always listen to your team. A different case where a linter is not a good tool for a problem is when you need to know the value of something. So for instance, if we want to forbid divisions by 0, if we see A divided by 0, that's easy, we're going to report it, which is fine. But what if we see A divided by B? Well then, we need to figure out whether B is 0. And to do that, you're going to have to make a lot of computations, a lot of fetching data to figure out, is B 0? And if B is, for instance, a parameter, or if it comes from a different module, or if it's a global variable that can be touched anywhere, basically you're trying to write an interpreter for your entire language, which is very painful to do, and extremely expensive in terms of computation, and often for very little value in practice. And often, in most cases, actually just plainly impossible. So when you need to do this, linter is not a good tool. And also, simply, just to reiterate, if you can't tell a problem just by looking at the code, then linter is probably not the right tool. Maybe you can combine it with other tools, like that we've seen before, like moving things to a different module using your type system, running some tests, and then you can combine it with your linter. So that whenever there's a problem, you can sell it just by looking at the code. So guarantees, they can help you prevent bugs in the future. I would really recommend that the more you work on a code base, the more you add guarantees to your project. This is one of the reasons why in the Elm language we try to use a type system for a lot of things, and we try to make sure that every possible bug would result in a compile time error, and that makes us able to go really quickly, to develop really quickly. So you have different tools at your disposal: types, the type checker, tests, dynamic analysis, linters, TDD, pair programming, all those things. Try to use them together to create the guarantees that you want, so that you can keep on working efficiently without introducing bugs. Thank you very much.